Hi everyone, welcome back to our channel. Today we are going to discuss the power plant or power source characteristics. Already we have been discussed in the previous class how the vehicle power source characteristics, the tractive force, the torque on the wheel, the tractive force developed by the IC engine, and speed of the drive wheel and velocity of the drive wheel. Now let's try to draw these characteristics. So in order to draw these characteristics, it's a very simple. Actually, we know only two characteristics what we draw in x-axis and y-axis, but here you have multiple axes. You see here, so this is y-axis, this is x-axis, this is z-axis. Okay, so you are going to take three axes of control. On the x-axis I'm taking the speed as an reference on the x-axis. On the y-axis, this y-axis I'm going to consider the torque characteristics, and this axis I'm going to consider the power characteristics. Now let's try to establish a relationship between these three parameters. So coming to here, so we have the formula for power. Okay, so power is equal to torque into omega, where omega is nothing but angular velocity. Therefore power, so now we need to establish an relation. So power is equal to torque into, how to write an omega? Omega can be written as 2 pi n divided by 60. So this is what the relation we have generally. So now let's try to draw its characteristics. So now initially, so we have parameter 1, parameter 2, parameter 3. So initially less than base speed I am assuming the torque is constant. Okay, so initially I'm taking torque is constant. If the torque is constant in this expression, if the torque is constant, then power is directly proportional to 2 pi n divided by 60. I can say that power is directly proportional to speed. So let us try to see here. So, and we can have the relationship here: power by torque is equal to speed. You see here, power is there, torque is there, speed is there. So power by torque I can write down an approximation like this. So now, so I'm starting with lower speed, and here I'm marking some, this is the minimum speed or critical speed, and here slowly 100 rpm, 200, 300, 500, 600, 700, and I'm assuming this is a maximum speed and still continues. Okay, at one speed what I've been assumed is, first one is torque is constant. So I'm assuming the torque is constant to this axis. So here, what is constant? You see this torque magnitude is constant. So torque magnitude is constant at an minimum speed. At this point torque is of minimum. Now when the torque is constant, what is the relationship between power as well as the speed? They are directly proportional. Therefore the power and this are going to vary. Okay, you can see here, so slowly the power and torque are reaching this point. So here I can say that power is directly proportional to speed. So this is one kind of relation. So now under constant torque, so power and speed are directly proportional. So at this point I can say that the electric vehicle is going to have at, so here you can see here what is the speed offered. Speed is minimum. Automatically the power is also minimum, but it offers a highest torque. Actually all the electric vehicle are also exhibit the same concept. At low speed they can deliver maximum torque. At low speed they can deliver maximum torque. This is generally experienced by PMSM motors, which is nothing but a permanent magnet synchronous motor in a practical electric vehicle, which is nothing but Ather. So the brand Ather EV also exhibit the same characteristics, which is nothing but a permanent magnet synchronous motor. At low speeds, it can have high torque. This is why the advantage of this PMSM motor. So same characteristics are also generally given by an internal combustion engines. Okay, which is called ICE engines. So this is one part of characteristics. Coming to the next part of characteristics, so here, so this is the first step we assume. Second, what we are going to have is, let us assume now power is constant. So from the above expression, if power is constant, if the power is constant, you can write down, so P by 2 pi n, P by 2 pi n into 60 is equal to torque. So now what are you again saying, that power is constant. Therefore I can say that torque is directly proportional to 1 by n. So torque and speed are having inverse relation. Torque and speed are having inverse relation. These characteristics are also called hyperbolic characteristics. So these are called hyperbolic characteristics. Let us try to experience this. So now whenever the speed is increasing, okay, so whenever the speed is increasing, and here we are assuming that what is constant, power is constant. So whenever it comes beyond the minimum speed, here we have the power is constant. Whenever the power is constant, so then you can see here what is the relationship. So power and torque are inversely related. So power and torque are inversely related. Speed is increasing, then what is going to decrease? Torque is decreasing. Then you are going to get the characteristics like this. So I can say these characteristics are nothing but hyperbolic characteristics. These are hyperbolic characteristics. So our IC engine is going to exhibit these two characteristics. When you join these two characteristics, so these are the characteristics exhibited by our internal combustion engine. You see here the darkened line, what I am showing are the characteristics exhibited by an, so these are the characteristics exhibited by an power source plant, or is nothing but a power source. What is the power source here? Engine. So these are the characteristics exhibited by an engine in the case of an internal combustion engine. So when you come to here, the same concept is also once again applicable here when you come to electric vehicle concept also. So in electric vehicle also the same phenomena is applicable. So in electric vehicle also the same characteristics we are going to get. So here also we are going to plot the three characteristics. One is x-axis, next two are y-axis, and here you are going to have the power, and here you are going to have the torque. So the formula is same. So we have power is equal to torque into omega. Omega can be written as 2 pi n by 60. First case is torque is constant. Whenever the torque is constant, then power is directly proportional to n. So when power is directly proportional to n, we are taking some minimum speed where this is called as a critical speed or critical. So here the x-axis you are going to have the speed similar characteristics. So from here to here we are going to have what characteristics? Constant torque characteristics. In these characteristics, power and see here power as well as speed both are directly proportional. So up to which speed? Minimum speed, or the speed is called as a critical speed. But when you come to the next session, so here I'm taking next one is power is constant. When power is constant, what is the relation we are going to have? Torque and speed are have inverse relation and they exhibit. So here what we are going to have, power is constant and the vehicle is experiencing an inverse characteristics like this. Here I can say torque and speed are inversely related. They are connected with hyperbolic characteristics. So this is the resultant characteristics exhibited by an which engine, which is nothing but which uses an motor. So the vehicle which uses a motor, which is nothing but an electric vehicle. So these are the power source characteristics of an internal combustion engine and power source characteristics exhibited by an electric vehicle. You can see here these two are same. These two are having similar characteristics. The performance exhibited by an internal combustion engine is also exhibited by an electric vehicle. So we can have the internal combustion engine can be replaced with EV engine. So this is about the power. So this is all about the power source characteristics of an IC engine in comparison with an electric vehicle characteristics. But when you come to this have only one gearbox, nothing else in electric vehicle. But when you come to the multi-gate transmission, okay, let's try to write down what happens in multi-gate transmission. So tractive effort. So what is the tractive effort generated by an IC engine when we have multiple gates? When you have multiple gates, let's try to see how the tractive effect is going to change. So here I'm drawing the graph. On the x-axis we're going to have the speed in kilometers per hour. So 20, 40, 60, 80, 100, 120, 140. Just take an two-wheeler which has maximum 160, and you can see here on the y-axis you are going to have tractive effort or tractive force. This is the force exhibited by the vehicle to propel or to move. So the force exhibited by the engine or the IC engine or the EV to propel on the road. So when you have this system, so you can have the graph like this. So here I'm having, so the graph is like this, is declining, and you have first gear here, and you have second gear here, and here you have third gear, and here you have fourth gear. Sir, what is this meaning of first gear and second gear and third gear? So this is first gear, this is second gear, this is third gear, this is fourth gear. You see here, generally these IC engines are designed like this. In the first gear, you can see here that first gear means when you are connected to the first gear, the speed offered by the vehicle is low, but it offers highest tractive effort or highest tractive force. So these sort of vehicles, I mean at low speed, they offer high tractive force or high tractive torque. These vehicles are called generally in practical way developed by IC engine. In electric vehicle, they are also developed by PSM motors, which is called permanent magnet synchronous motor. These permanent magnet synchronous motor are designed so they can give you at low speed. The vehicle is running at 20 rpm, I mean 20 kilometers per hour, but it can offer good torque, good tractive force. So at first gear, you can see here, at first gear the IC engine is also offering the same. The IC engine, you see here, we are comparing IC engine with respect to an electric vehicle. You can see here both will give same characteristics, but the graph is same. Why? Because we have different gears, but rather than multi gears we have only one gear. That's all. This is one of the difference you can see here. In the first gear the speed is low, but at the low speed it is having more tractive force or tractive torque. Coming to the second gear, in the second gear generally what you can happen, you can have better speed. So the speed is increasing. So in the second gear you have more speed, and automatically the tractive torque which is developed, I mean the pull is very less. Why? Because already you are running in second gear. So when you come to the third gear, so the speed is increased, and automatically the tractive force is also nominal. When you come to the fourth gear, okay, the fourth gear you have the maximum speed. So the vehicle is trying to run with maximum speed, and torque is very minimum, not minimum, it's like moderate. So the first gear, for example, we're driving an inclinating line like this, for example a hill like this. So in this hill you are having some sort of to this hill you are having some sort of gradable angle. So it has to move on this hill, means what it requires. So at low speed the IC engine, at low speeds the IC engine has to offer high tractive. So that is 100% developed by an the multi-gear system. So when you similarly draw the graph for this, For an electric vehicle also the characteristics remains same. Okay, let's try to experience this how the characteristics are same. So when you try to draw for an IC engine, so when you try to draw for an IC engine, the characteristics are also same. So you also get the same characteristics like this. But rather than multiple gears, you have only one graph like this. So this is nothing but speed versus tractive force experienced by an which vehicle? Electric vehicle. And you can see both the characteristics are same. So that's how we can say that the tractive effort generated by an IC engine as well as electric vehicle both are same. So this is the graph which shows you, so this is a graph which shows you how the tractive force or the tractive effort of an IC engine. So this is the tractive effort developed by an IC engine. This is the tractive effort developed by an electric vehicle. Both are same. So since you have different gears in an IC engine, you have these characteristics. But if you draw for EV also, this is also same. Almost all, if you draw the path, already I told, so at different speed, minimum speed, and it is called critical speed, is nothing but maximum speed. And here you are going to have the tractive force developed by an electric vehicle, which is permanent magnet. So here also, this also will have same characteristics. I can say that these two characteristics are same. Therefore, I can say that an IC engine can be replaced with the help of an motor. The help of a motor is there in EV. So, the replacement for IC engine is nothing but completely an electric vehicle when you compare the tractive forces and when you compare the power source characteristics. This is all about This is all about power source characteristics. I mean vehicle power source characteristics. The speed power torque characteristics are similar to that of an IC engine. Therefore you can replace the IC engine with an electric vehicle. And coming to the tractive effort developed by an four wheeler, I mean with multiple gears, and the tractive effort delivered by an EV, both are same. So I can replace an IC engine with an electric vehicle motor which exhibits all these things. Hope we able to understand the power source characteristics. In the upcoming video, we'll try to proceed with. So, what are the different characteristics? Those are called as vehicle performance characteristics. So, hope if the video is useful to you, please like to our channel and please share with your friends and please give your valuable comments positively or if you have any doubts. So please share with your friends and try to promote our channel. Thank you for watching. Yours faithfully, Ram. Thank you.